In this lesson, you will learn to factor perfect square trinomials. So you will follow the rule for factoring perfect square trinomials by taking the square root of the first and last term. Always check the middle term. It must equal 2 times a times b, and the sign depends on that middle term of the trinomial. You will write your answer in factored form. So let's first make sense of the rule. If we took the binomial squared and wrote it out, a plus b times a plus b, we can use the distributive property or the box method to multiply this back together. So we'll do a times the a plus b and b times the a plus b. When we distribute, we get a squared plus ab plus, we'll write this one also as plus ab, so we'll be able to combine our like terms, and then plus b squared. Notice even if we were having a negative, it would work a lot the same. We would just have to be cautious of our signs. If we combine our like terms here, we get a squared plus 2ab plus b squared, just as the perfect square trinomial rule says. So let's look at some examples. Our first one, we should notice that the first term is a perfect square, the last term is a perfect square. And we also need to check the middle term to make sure that it equals 2ab. So to do that, we'll first take the square root of the first and last term. You write that as b equals. So the square root of our first term gives us 5x. The square root of our last term gives us 6. Checking that middle term is important, but it's really a perfect square trinomial. So you'll do 2 times your a times your b. So 2 times 5 gives us 10, and 10 times 6 gives us 60. So that does equal 60x. So in some way, always make sure you check that 2 times a times b. So to write it in our factor form, we just take our a term, which is 5x, and then our b term, which is 6, and it takes the sign of the middle term. So we have plus, and it is quantity squared. So your factor is going to have the same sign as the 2ab term from the trinomial. So because we had a positive in that middle term, we have a positive for our factor. Let's take a look at another example. Again, we notice the first term and last term are perfect squares. So we're able to take the square root of each of those terms to find our a and our b. The square root of x squared equals x. The square root of 49 equals 7. So we want to check that middle term, 2 times x times 7. Well, 2 times x times 7 does give us the 14x. And of course, as far as the sign goes, when we put it in our factored form, we will make our factor match that sign. So let's do that now. Our factored form will be x and 7 with the quantity squared, and our sign will be the same as that middle term, so a minus. So again, making the note that we get our sign from the 2ab. It will always have the same sign as the 2ab. If this matches, when you check that middle term, then you can factor it using this perfect square trinomial rule. Let's take a look at number 3 now. Again, we notice the first term and last term are perfect squares, so let's take the square root. So the square root of 4y squared gives us 2y. The square root of 81 gives us 9. When we check 2 times 2 times 2y, so 2 times 2y times 9. Well, 2 times 2 is 4, and 4 times 9 does give us 36, so that one is checking out also. So it's just as simple as our factored form to be 2y, taking the sign of our middle term, so 2y minus 9 quantity squared. And of course, like any factoring, you can multiply this out, 2y minus 9 times 2y minus 9, and use the distributive property or box method to check that it truly equals our original problem. Let's take a look at number 4. This one looks like a perfect square trinomial. The first term and last term are perfect squares. But this is where it's so important to check your 2AB, because if the trinomial is not a perfect square trinomial, then you'll have to use another method that you'll learn in another lesson. But right now, let's look at this one. If I take the square root of x squared and square root of 16, I get x and 4 for my a and b term. But when I check 2 times x times 4, well, 2 times x times 4 gives me an 8x. So we cannot say that this is not factorable, because it might be factorable by a different method, but we can just say that it's not a perfect square trinomial. And I just use the abbreviation, not a perfect square trinomial. It may be factorable, but just not by this method. So you would need to use a different method for factoring this problem. Our last one now for the perfect square trinomial, again, checking that first term, taking the square root, and last term, we get x and 6. And we notice again, 2 times a times b, that does not equal what we needed. 2 times x times 6, that actually gives us a 12x. So again, not a perfect square trinomial. And that's why it's so important that you check that middle term for the 2AB. But also notice something with this problem. The last term, to even be able to be a perfect square trinomial, the last term must be positive. So already from the start, if we would have noticed the minus 36, a negative 36 in no way can be a perfect square. So this already would have been not a perfect square trinomial. But it also helped to check that 2AB.